let's read the directions. Find the absolute maximum and absolute minimum values of each function. Stop right there. Let's make sure we're reading it carefully, because it said find the absolute maximum and absolute minimum, the highest, the lowest, values of each function. Find the highest value of the function. Finding the highest value of the function doesn't just mean I have found the x value where I have the highest value. So let's just get a little visual here, just because we're going to be dealing with the parabola in just a minute that is upside down, and we're going to go from 1 to 6. And anyway, it may or may not look exactly like that, but it's something like this. And I could look at this and say, well, look at that. That is the highest point, and I might be tempted to say, let's pretend like that's 3. Okay. I might be tempted to say the absolute maximum is x equals 3. No, it's not. The absolute maximum is the y value associated with it. So there are a lot of students that can get points taken off if they don't read carefully. Find the maximum minimum value of the function. So when I'm done, I have to find f of 3, if that's even the answer to this one. Just made that up. So let's keep reading. On the interval given, if possible. Now, why wouldn't it be possible? Okay, they're asking maximums and minimums. If they're asking for maximums and minimums, that is a value of extreme values. That's a matter of extreme values, I should say. We're dealing with extrema. The extreme value theorem says I can only find maximum and minimum values if the function is continuous. So step 1, do we have continuity? Yes, we can. And yes, we do, so we can do this. So we are going to find the derivative of this. Maximums and minimums occur where the derivative equals 0. Ooh, it is going to be 3. Or where the derivative does not exist. This derivative is going to exist all over the place. It's fine. It's quadratic, upside down, smooth curve. We're fine. We'll set this equal to 0, and we will solve, and we get 3. So we truly do have a potential maximum or minimum at 3. Well, we also have to consider, again, anywhere that the derivative does not exist. And this derivative is going to exist anywhere, so we're fine. Also, we have to consider the endpoints of an interval, because I might have a high or a low point there at 1 or 6 or whatever. So what I recommend you do is make a little table out of it. This is, for me, the best way to do it. And this is the way a lot of people organize their thinking. We'll have x values, and we will have f of x values. And I used to do the table sideways. I've just now decided I think it's going to be best if we do it this way, so we can do work over off to the side. Do it whichever way you want, though. So I need to consider every endpoint of an interval, so 1 and 6, and also anywhere that the derivative is equal to 0, that'd be 3. And I'm going to plug those values into the original function. We can do some of this in our head. So again, we're dealing with the original function. We're not dealing with the first derivative. We used the first derivative to come up with this. This is where the derivative equals 0. This is a potential critical point. So I'm going to plug in a 1. I plug in a 1. I have 4 plus 6 is 10 minus 1. That's going to give me 9. I'm going to plug in a 3. When I plug in a 3, I have, let's just do it on the board. 4 plus 6 times 3 minus 3 squared. And so that's going to give me 13, I believe. And I'm going to plug in a 6, and that gives me 4 plus 36 minus 36, so that's easy, 4. Okay, so I need to know the absolute maximum and the absolute minimum of this function on this interval. I'm looking for the highest and the lowest values, so don't make it harder than it is. You have your list. So now I have found the absolute maximum. I'm going to call it the absolute max, abbreviate a lot. And the absolute value, the absolute maximum is 13. I'm going to be a little more specific. It's at 313. It's okay to tell the location, but don't leave out the y value. Don't say the absolute maximum is x equals 3. No, that's the location of the absolute maximum. That is not the absolute maximum. I don't know why I'm running in place. The absolute minimum, looks like separate sentences that weren't capitalized, is, well, the lowest y value I see, which would be 4. That'd be 6 comma 4. Okay, so we have just answered this question, and it was indeed possible. Let's move on to the next one. Feel free to pause it if you need to copy something. And the next one, move my calculator out of the way, x cubed minus 6x squared plus 9x plus 1. X cubed minus 6x squared plus 9x plus 1. And this is on the interval from -1 to 4. Okay? And we're going to do the same thing. Well, first of all, is this function continuous? Yes, polynomial functions are continuous, so no need to worry about that. We're going to be just fine with this. Here we go. Let's do that. Also, a second question, does this function ever have a place where its derivative would not exist? Well, let's take the derivative first. And I think it's going to be a fairly obvious answer. Does this derivative always exist? Yeah, you're never dividing by 0. We're never doing anything wild and crazy like that. But we will set this equal to 0. We'll factor out a 3. You can do a lot of this in your head if you like. The marker is right beside the microphone, so you're just hearing lucky you. Okay, I need to consider every place where the derivative doesn't exist, not an option here. Everywhere that the derivative equals 0, which would be 3 and 1, and every endpoint of an interval, we're going to plug all those in. So endpoints of the interval would be -1 and 4. I'm going to just put these in order. It's best if you do. Not wrong if you don't, but it's best if you do. It's a little more organized. And then the other possibilities, the other places where I could have a critical value, and that would be 1 and 3. So we plug in the 1 and the 3 and the -1 and the 4, and I'm going to jump to my calculator for this one actually and type it in. I don't know why I wanted to sing that, but I wanted to sing that. 6x squared plus 9x plus 1. And I will plug in a -1. Can't see what I'm doing, so how boring it must be for you right now. Okay, -15, that looks pretty low. 515. Okay, we are looking for the absolute maximum, the absolute minimum, and I believe we have found both, so here we go. The absolute maximum on this interval is, okay, more than one of them. It's a tie. Well, actually, it's not a tie. It's a microphone. I was wearing a tie. I'm sorry, bad joke. It's a tie between these 2 points. Put them both. It's okay. You can have more than one absolute maximum. They are equal in height. So 1, 5 and 4, 5, which at this point means we're correct, but we have bad grammar. The absolute max says R. You don't get points off for bad grammar, but you know, it's just frustrating for me. The absolute minimum is at -1, -15. That's it.